Good morning, and thank you for joining us for a live talk with Anushka, who is a graduate engineer at McLaren Automotive, which is a creator of luxury high-performance supercars. It's great to see so many schools on the call today, and we're sure you will enjoy this webinar. To celebrate Green Careers and tomorrow's Engineers Week, Anushka will give an insight into her career journey to date and why she chose to study engineering. And she'll also talk about her experiences of working in the exciting automotive industry. Please feel free to ask any questions by putting them into the chat, and Anushka will aim to answer those at the end of her talk. So that's enough from me. I will hand you over to Anushka. Good morning, Anushka.
Good morning, Lisa. Thank you for the introduction. Good morning, everyone. So welcome to this talk on Wednesday morning. As Lisa explained, the talk today is basically about green engineering and tomorrow's engineers, as that's the week we're celebrating. And I'm currently working at McLaren Automotive, and therefore that's sort of going to be the base for my presentation today. I'm Anushka Mukherjee. So I'll just give a quick overview on what we do as a company. So we are essentially McLaren Group, which is broadly divided into two main divisions, I would say. So we have McLaren Racing, that is the team or the division of the company that takes part in the Formula One races that we see year round. And we have McLaren Automotive that builds these high performance luxury cars, which are also known as supercars these days. And so McLaren Automotive is the division that I am currently a part of. We also have some more divisions that work in collaboration with racing and automotive. And that is basically, we have Formula E, we have IndyCar, we have the Extreme E, we have the GT championships. And all of that is, like I said, a collaboration between taking some of our existing products and making them available for use in different scenarios, different competitions, for example. I just have a quick video of McLaren as brand. So just look at this, and this is an insight of what McLaren as brand is and what we do. Well, I hope you enjoyed that thrilling video. Every time I watch it, it makes me very excited to be a part of this brand. And like we saw towards the end of the video, prepare, commit, and prepare. What I also like, one of our recent launches of the 750S was taglined as benchmark beaten. It basically indicates how we're always striving to improve on our own performances. And that's the principle that we all follow here at McLaren. Well, how did I get here? So this is sort of how my road to McLaren looked like. I am from India, so I have done my schooling in India itself. So what we call the A levels here, for example, it's the structure is slightly different in India, but in my equivalent of A levels, I essentially studied physics, chemistry, math, and biology, the quintessential science student, if I were to say so. And thereafter, I decided to study mechanical engineering in India itself. Why mechanical engineering? It's because mechanical engineering has been one of the core fields of engineering since we know engineering as a subject. Mechanical engineering leads to one of the most interdisciplinary opportunities in engineering as a field. And I believe opting for this field allowed me to have the flexibility to look at different industries, different products, for example, different systems. And these are just some kind of the projects that I did at my undergrad level. One of which, so this one is a very prototype level of carts in this sort of vehicle in India, which we wanted to improve in terms of usability for the people who use it on the streets of the country. And this was another project down below here, which was basically a very environmental approach taken to study machining processes. And the idea behind this was to use biolubricants to use on the machining of metals. And we know we need coolant, and those coolants are chemical in nature, strongly chemical in nature, and that obviously poses a hazard to the industry. And therefore, the study on using biolubricants was an approach towards indicating that we can have these industries, these machining processes of metalworking, for example, in a more environment-friendly way. From there on, I worked at Mercedes-Benz Research and Development India. So that was my first step into the automotive industry. I started with an internship there, and soon after that, I was absorbed as a graduate engineer in the thermal comfort department. What that allowed me in those 2 years was I got an insight into two different departments of a car. One is the exterior lighting, which is run by a lot of regulations on what is visible to the road, what is visible to users, oncoming traffic, for example, colors and things like that. So that was something we tend to overlook when we are thinking about a car, but the exterior lighting has quite a bit of technicalities that go into it. And in terms of thermal comfort, this was about the air ducts in the car. So when you sit in a car, you have the AC on, you set it to temperature, hot or cold, and this air has to reach both the driver, the passenger, but also the passengers sitting at the back of the car. We do that using ducts, and my role was to basically design those ducts for the Mercedes-Benz cars. From there on, I stepped into yet another department, which was battery thermal management. I'm sure you're all aware batteries are the upcoming thing, and the batteries get hot, and we know batteries are prone to fire. So if these are not thermally managed, this can pose a risk to the driver and any traffic around. So this was about performing some simulations and analysis to understand how the temperature varies and how we can control it by doing some studies prior to actually building this into the car. This was approximately 2 years ago, shortly after the pandemic, which is when I decided it was time for me to explore the international scene on engineering fields and the automotive industry. So how I chose to do that was to come to the UK to pursue my master's in mechanical engineering. And this was at the University of Sheffield. Why again mechanical engineering? Because I still believe that mechanical engineering allows a very broad scope of opportunities. And this is why I focused on an advanced mechanical engineering degree rather than diving into technical details of one field of mechanical engineering, for example, manufacturing or structural strength or materials, for example. I believe, again, this was the right choice because that's what got me here at McLaren Automotive. I have joined McLaren Automotive just at the beginning of this year, so I have been here less than a year now. But I work here in the powertrain systems team as a graduate engineer. So the powertrain systems is everything from the engine to the exhaust of the car. And I work on the cool bits, which is the exhaust, which is what makes the McLaren cars sound like they do. So we have the exhaust systems, we have insulation to make sure that the heat from the exhaust system doesn't affect the car and the passengers inside, and sound generation. Like I said, it's what makes the cars sound cool. This is what I currently do at McLaren, and I believe it's given me a great opportunity to contribute to the automotive industry in ways we only imagined while growing up. And I'm living the dream now, to be honest, and I've loved it so far. So to just jump into, since we're still at the school level, what is engineering? So engineering essentially is a combination of three factors. One is mathematics, one is science, but most importantly, I would like to say, is imagination. And why that imagination aspect is the most important is because creativity is the need of the hour. the kind of problems that we have in the world today, the kind of challenges that humanity is facing or the industry is facing, is often resolved by the most creative solutions, by engineers or by anyone that thinks out of the box and can propose a unique solution to an existing challenge, which is why imagination is one of the most important aspects of engineering. Science and mathematics are basically tools to then convert that imagination into reality, into a feasible solution. So what is the engineering design process then? It's a circle, which means this is a process that is constantly moving in a cyclic way. There's always feedback and interaction and collaboration between many different teams working on the same solution. So, of course, we start with what is the challenge, what is the need of the hour, what are we trying to resolve with this with the situation at hand. Once we know what the need and the requirement is, we then work towards researching the problem. That is to understand why it could be happening. This means understanding the root cause of the problem, and there can be more than one root cause. Once we've identified that, we imagine, we look for the possible solutions and see how we best choose the correct solution out of the many options we have. And this is often affected by things such as cost, time, feasibility of the solution, and practicality of the solution, for example. The next would be the planning of the solution. So once we've got the choice of solution in hand, we have to plan it in a way that we can implement it at the correct time to the correct problem and make sure that all the teams are aligned and following the same time plan. The next step would then be to create a prototype before we actually put it into the car. So the prototype often is done at maybe a smaller scale or in a test setup, for example. And this prototype is then used to judge the solution's accuracy in solving the problem. After which we then test this on, we use this prototype for testing. Once you've tested it, we have some feedback on how it performs and what can be made better, which is the next step then, which is improving and redesigning as and when needed. And this is a constant loop of engineering as we know it. So quick little jump into history. McLaren started as a racing company back in 1963, as I'm sure most of you would know. And from there on, we have had a very rich and treasured history of the kind of products, the kind of progress that the company has made. We started out as a racing company, but today we are a lot more than that. We are one of the few supercars companies that started from racing and has then ventured into the passenger car segment, whereas it's quite often the opposite in a lot of other cases. But this is what McLaren is today. So this, the top left corner is the McLaren Technology Centre, which is where the company is headquartered. This is where most of the product development and planning takes place. Then we have the McLaren Production Centre, which is where we build all these fancy cars. So we design them here, we build them here. And of course, we have suppliers where the parts get made and we assemble them at the production center. And this is where the cars are made and then sent out to the public. We have approximately 3,000 people, I want to say. And we have the capacity to produce over one car every 32 minutes, going through the cycle of the production. Top right corner then is Idiada. So we have a facility at Idiada, which is essentially our test center. So this is where we perform some of our main tests on the vehicles. This includes durability running, crash tests, for example, the handling tests, and all of this is basically done on a racetrack. It's called a proving ground, and you need a special license to be able to drive on those tracks because, well, these cars are very powerful. So we need to make sure that only the people certified to drive are driving these cars to perform these tests. And then in the bottom right corner, we have MCTC Sheffield, which is our most recent facility. This is where we are currently producing our carbon fiber, the chassis, the tubs that we use in our cars, which one would argue is the skeleton of the car. So this happens at our own facility in Sheffield. So just to then look at where we are in terms of the market today. So for our current vehicles, I'd like to, let's say, plot them on two main factors. One is the cost of the car, and one is the performance of the car. So when I say performance, we essentially have the more practical and the road feasible car, and then we have the track focused cars. So this is some of the products that we have had in the past and we are currently still producing. The idea behind this chart is essentially to say that we have cars for different segments of the market. And for example, the McLaren GT is one of the most practical cars, and it is also low on cost. But if we move up in this graph and look to the top right corner, for example, this is the Solus GT, which has recently been announced as a track-only car. This has been designed with a racing performance in mind, and the driver's seat has essentially been designed in a way to replicate the cockpit of an airplane. So you can imagine what kind of performance we're talking about. So this is the idea behind these cars is basically, yes, they're expensive, but the idea is that we are trying to make the car the best in its segment. So for example, the Speedtail is the fastest car in a straight line that we could have made at that time. So that has a record of its own. And the Senna, for example, is the fastest thing on the track. It means that it has great turning capacities, it has a great handling, great suspension, great dynamics behavior, for example. And then we have our Artura and 750S, which are the current cars that we have going in the market. And both of these are somewhere in between. They are practical road cars, but they have the performance, they have the power, and they have the design that they can be used on a track, for example, in the GT3 championships. So that's what we do. Like I said, it's a collaborative effort between all the divisions at McLaren, and this is where we stand with our current portfolio of these cars. So this is a quote famously said by Bruce McLaren: "Life is measured in achievement and not in years alone," which I think stands as a testament to what McLaren as a brand has done, which is to say that in a very short span of time, roughly 60 years, we've only celebrated the 60th anniversary of the company this year, but we have made some fantastic progress over the years. We've been pioneers in terms of innovation, and it started with having the introduction of the lightweight chassis of the carbon fiber in Formula One, so which was a step quite ahead of its time, one might say. And then thereafter we have the McLaren F1 road car, which was one of our first road cars, and since then we have always had the carbon fiber chassis in our cars. And why that is important is because it contributes to the lightweightedness of the car, which then directly feeds into performance and sustainable usage of the car. We also have the McLaren P1, which was the world's first hybrid supercar. And again, this was back in 2012. And yes, the hybrid element is to have a battery pack support the engine in running these cars on the roads. And every company now, everyone in the automotive industry is moving in this direction. So yeah, it's quite an important aspect. And then we also have the Artura, which is again one of our hybrid V6 engines. So yeah, it's all about how we make the most in what little time we have. So what do we need to think about in making a car? So we have safety, we have reliability, we have environment, we have performance, we have cost, and we have technology. For today, I would obviously focus on environment and technology because, like we said in the beginning of the presentation, we're celebrating Green Engineers Week and tomorrow's engineers. So I just have a quick list of things on examples of green engineering innovations in the automotive industry. We have electrification, as we all know, is the need of the hour. We are looking to reduce our consumption of the fossil fuels, and electrification is the best way to do this. And whether that means full battery electric vehicles or hybrids, that is something that the industry is constantly developing and evolving in. Then we have sustainable fuels, because batteries have challenges that we are all aware of in terms of the life of the battery, the recycling of the battery at the end of its life, and how we can then use sustainable fuels in our existing engines. So that is one big field of research at the minute. Then we have lightweighting, which, like I said, lower the weight of the car, better performance, less fuel consumption. So again, important in terms of green engineering. We have composite materials, but I would say this applies to material sciences in general. Composite materials contribute to using some artificial materials to provide the same structural strength and performance as and when needed inside a car. We also have the circular economy and the 4R environment, which refers to the reduce, reuse, recycle, and recover. And this applies not only in the manufacturing of a product, but in the entire economic cycle, which includes the sourcing, the supply chain, the transport of the raw materials, and the waste at the end. So again, all of this does directly contribute to the green engineering. And this is because each of these processes contributes to the carbon footprint of a company, which we all know is quite an important factor to consider when a company is in the works today. And everyone is now on targets to reduce these to as low as possible. And directly when the car is running, we have emissions controls. So this is run by, again, within the exhaust system, for example, on how we convert these harmful emission gases into something that we already have in the environment, for example, water, carbon dioxide, and nitrogen. And then we have digitalization and artificial intelligence and machine learning. Why I call these also green engineering is because digitalization has enabled us to have connectivity in the automotive industry. There's communication between vehicles. There is the hybridization. There is optimization of the drive cycles, optimization of how, for example, the valves in an engine can be timed based on the use cases and how each driver drives differently. And these can all be then imbibed into the performance or the running of the engine. And this is a constant field of study that we have in the industry today, in academic and the professional industry as well. And artificial intelligence and machine learning also contributes towards, in terms of the circular economy, like I said, in optimizing certain routes and optimizing, for example, the kind of things that would then contribute directly into having total carbon footprint of a company in as low as possible. So this is the automotive industry. It's a very huge industry, and there's always so much going on within the industry. And I think one of the most important things to understand is that engineering is one of the ways to contribute in the automotive industry. But we have STEM, and STEM is much larger than just the science, technology, engineering, and mathematics. So when we talk about how we can contribute to the automotive industry as green engineers, or just green industry, I were to call it that, is we have a spread of fields of study which all contribute to the automotive industry and the revolution that we are currently in today. So we have, of course, our natural sciences, physics, chemistry, biology. We have applied sciences, which is mathematics, statistics, design, environmental studies, which contribute to the automotive industries in such ways such as statistics of the customer use, for example, in terms of environment, and how we use our natural sciences to then control, for example, emissions and sourcing sustainable materials. We have the social sciences, which is the economic, psychology, and business studies. Again, this directly feeds into how users are looking at the car, how the general public perceives supercars as an industry, and the environmental challenges that the world is currently facing today, and how we can build the correct business model to make the company as sustainable as possible. And then we have the humanities, which is the law and the arts, which again also feeds from the psychology and the human behavior, as we were to say, and the law directly contributes to the regulations, for example. So as you can see, all of these fields have at least one foot in the door when it comes to the automotive industry. So this is, I would say, engineering is one of the many ways to get into this industry, but you don't have to be an engineer. You don't have to love science and maths. You can get into the automotive industry and work for a company like McLaren, even with any of these other fields. So I would like to end the presentation with saying, enjoy what you do, because I think that's the most important thing. You should work because you like what you do, not just to, go to an office 9 to 5. If you enjoy your job, it feels less like a job, and you will never work a day in your life. And one of my other favorite quotes is, the jack of all trades is a master of none, is what we know. But the full quote is, jack of all trades, master of none, but oftentimes better than a master of one, which means spread your wings, learn as much as you can, and you will be a value add to any kind of industry or any kind of organization that you work in or contribute to or volunteer for or in any capacity interact with. So yes, that's the end of my presentation. Apologies, I have slightly run over. But thank you very much for listening, and I would be happy to answer any questions now.
Thank you, Anushka. That's so interesting. And as you say, yeah, you have run over slightly, but there's just so much to say. And isn't it great to see women in engineering as well? Must point that out. So thank you very much. We have lots of questions coming in, so we'll try and get through as many as we can. So I'll hand you over to my colleague, Sophie, to put those to you.
Right. Thank you, Lisa, and good morning, Anushka.
Good morning again.
So, our first question says, why did you want to work in your current job?
Well, good question. Like I said, I got into the automotive industry quite early on, right after my undergraduate studies, and I realized very quickly I like cars. Let's not beat around the bush on that. But my current job was more towards what runs the car, so the powertrain, and I felt that was the best way to contribute. And like I said, we are currently, as an industry, facing challenges on how we optimize the engines, for example, or the emissions control. And I believe it is a field where I can contribute to by being innovative, by being creative, and just making the company come up with something new, for example. That's what I am striving for, and that is why I have joined this current role.
Okay, great. So our next question is, are there electric race cars?
Yeah, we do. So McLaren Group actually does have an electric racing car, which is the Formula E. There are slightly different regulations from Formula One in terms of what kind of dimensions the car can have, how much battery capacity you can carry, and things like that. Like we have with the Formula One race cars, there's a certain amount of fuel you can use. The electric race cars also have a different set of regulations. So yes, definitely, it does exist.
Okay, and so somebody's also asked about hydrogen cars. Would they work?
So could you please repeat that?
Hydrogen cars, would they work as well?
So they have been produced as concept cars, but hydrogen car is one of the sustainable fuels, as I spoke about earlier. It is one of the things we're looking at on how to make it more sustainable and let's say a large scale thing rather than small production batches. And we want to make it accessible to all divisions of public, all members of public, not limited to certain parts of the country or certain, let's say, classes or levels of society. It should be accessible to one and all. And hydrogen may be the start of this research, but we are all working towards finding other alternatives of sustainable fuel as well.
Okay, so I think that probably slightly answers the question: are the new and more sustainable technologies being developed for these cars?
Yeah, so yes, it is currently being developed. Like I said, so hydrogen fuel is one of the early contenders in this race. We have also, as an industry, looked at biosynthetic fuels or synthetic petroleum, for example. So yes, there is research ongoing. And like I said, a lot of different fields contribute to this kind of research or this kind of innovation in the industry. A chemistry student, for example, can directly work on understanding the chemistry behind petroleum and see how we can use other elements found in nature and still make an engine perform the same way. So yes, there are other developments ongoing. We're just trying to make it achievable as a large-scale industry and accessible to one and all.
Okay, so I've got on a slightly different topic here. What's your favourite part of the job?
My favorite part of the job is that no 2 days are different. I am doing something, no 2 days are the same, I mean. I am doing something different every day. Some days I am looking at 3D CAD, 3D design models on my computer screen. Some days I am in the production center looking at parts being fitted on the car. Someday I am speaking with the logistics team to understand when we can have parts for the build phase of the car. So making sure that we have the parts on site, then being in interaction with the testing team to test prototypes. So it's all very exciting mixed bag of tasks and activities that I do on a daily basis. So that variation or that diversity in tasks, I think, is my favorite part of the job.
Yeah, it does sound very diverse, lots of variety.
Yes, definitely.
Okay. So our next question is, what do I need to do an apprenticeship at McLaren?
So we have actually recently joined an early careers program. So in terms of apprenticeship, I believe we currently have less opportunities in apprenticeships at the minute. But what we do have is we have had it in the past, so we do it. Currently, we've recently launched the graduate scheme and a year in industry scheme. So that's the opportunities we are running for this year. But the apprenticeships do come and go. So yes, if we keep an eye on the website, that's usually where the opportunities are updated.
Okay. So our next question is, do I need to be good at maths and science to work in the automotive industry?
No. So like I said, math and science only feeds into, let's say, the engineering aspect of the automotive industry. But the industry is a lot more than that, even within McLaren, which is a relatively small to medium-sized automotive company. We have an entire design department which basically sketches. It starts on pen and paper, so that they sketch what the car should look like, which again, it's not really science and mathematics. You need to know what looks good on the car. You need to know where the engine would fit. You need to have an understanding of size and perception, but not science and mathematics. And you also have the commercial aspect, the product analysis. So that means research on what is the type of car we should do next. Do we have, let's say, like we have the 750S, which is basically the 720S older brother, or do we have a new car, like when we launched the Artura? So that's, again, a very different department from science and mathematics. And then, of course, we have production. So you would be actually building the cars. You would, for example, the bolts on this wheel, you might be one of the people that actually bolts this wheel to the car to make sure that the car drives safe. So there's a lot of different opportunities, a lot of different fields of study that are very useful in the automotive industry.
Fantastic. Okay. Do you have to consider the carbon footprint in your job?
So not directly in my job, not as part of my daily role, at least, let's say that, but it's the responsibility of every one of us in the company to contribute in every little way we can. So, for example, if I were to talk about how I address it in my job, is when we communicate with suppliers about the parts we want. Very simple things such as managing quantities. I want, say, 10 pieces next week and 10 pieces the week after that. It would probably be better to ship all 20 of them together so that we save on the transportation contribution of the emissions, for example, that would contribute to the carbon footprint. So those are the little things that I, in my role, can contribute to as towards the carbon footprint of the company. But there is, it's a larger department than it seems. And every one of us has small roles to play. But yes, as a company, we also work on this together.
Okay, so it's a collaborative effort. Right, so our next question is, I think this is going to have to be our final question as it is 9:15. What degree should I study if I want to be an engineer in the automotive industry?
Good question. Like I said, we have different fields of engineering within an automotive industry. Mechanical engineer, well, is called because that's how the car started all those years ago with the first ever car that was built. So yes, it would start with a mechanical engineering as a core option, but we also have fields such as manufacturing engineering, we have logistics engineering, we have environmental studies, we have electric engineers. The electric drivetrain, like I said, is a big part of the automotive industry today. Electric, we have software engineers, we have the computer science engineers. So it really depends on which part of the car you want to work on, and then choosing the right field of engineering to be able to contribute to those aspects of the car.
Okay, great. Well, thank you for that, Anushka, and thank you so much for answering all those questions. And thank you to everybody who put them in the chat and for watching in the audience there. I'm just going to pass over to my colleague Lisa, who will just finish for us.
Yes, thank you very much, Sophie, and thank you again, Anushka. That was so informative and so interesting, and we're sure that our audience has been inspired to hear about what types of careers and career paths are available within the automotive industry. But thank you again. Thank you to everyone who joined us. Enjoy the rest of Green Careers and tomorrow's Engineers Week. And we hope to see you all again soon in the future. Goodbye.
Thanks, everyone. Thank you, Sophie and Lisa. Goodbye.